Today we're going to talk about how to shift and reflect the graphs of parent functions. What we're going to do is we're going to graph some functions with no graphing calculator. So that's going to be different than what you are used to, or no calculator at all. No calculators allowed. So for a lot of the next few days, I'm going to ask you to do some things without a graphing calculator, without a calculator at all, but if we take the steps that I show you, it's not really that hard. Let's talk about the parent functions. You should have learned about the parent functions, or we'll call them the parents. The parent functions, number one, we already learned about f of x equals c, which is a constant function. We learned about that a week or two ago. And f of x is equal to ax plus b. That's the linear function. We already learned about that, and we had a quiz on that. The new functions that I'm going to talk about today are f of x is equal to the absolute value of x. So that is the absolute value function. The fourth one is going to be f of x equals x squared. That's the parent function for a quadratic. Number 5, f of x is equal to the square root of x, which is our square root function. And then the last one we're going to do tonight is f of x is equal to x cubed, which is our cubic function. So here's the form of the function, and those are the names of the functions. Like I said, we already did constant and linear, so I'm just going to talk about absolute value, quadratic, square root, and cubic on this video. So what we're going to do is we're going to graph, and I'm going to show you how to graph an absolute value function with no calculator. So absolute value, f of x is equal to absolute value of x. But what we're going to do is we're going to have to know the table of values, the xy table for these parent functions. And for the x values, the domain of this is all real numbers, so you can put anything in here you want. But let's start out with the integers -3, -2, -1, 0, 1, 2, and 3. And then the absolute value of x, the absolute value of -3 is 3, absolute value of -2 is 2, the absolute value of -1 is 1, and the absolute value of 0 is 0, and 1, 2, 3. So here are our x, y values, and if we wanted to put those in point form and then graph these, here would be the graph of an absolute value function. Label our x and y axes. And we went back to -3 on our x-axis and out to +3. And then on our y table, we'll go up to 3. So -3, 3 is the first point, -2, 2 is the second point, -1, 1 is the third point, and 0, 0 is this point. Then we have 1, 1, 2, 2, and 3, 3. So here is a beautiful absolute value function in the shape of a V. The next parent function we're going to talk about, and we've done lots of these in the past, is our quadratic function. F of x is equal to x squared. Well, again, the domain of this is all real numbers, so you can put anything in your x values that you want. And let's start with -3 again. -3, -2, -1, 0, 1, 2, and 3. And now what we're going to do is square all the x values. So -3 squared is 9, -2 squared, -1 squared is 1, 0 squared is 0, 1, 2 squared is 4, and 3 squared is 9. So now we've got 7 points that we can put on a graph. And again, when we go out to the x, I should be using the straight edge. So my graphs are a little bit neater, I guess. And then our y. So on our x values, we'll go back to -3, and then we'll go up to +3 on our x-axis, and then our y-axis. Actually, we don't have any negative values, so we won't go underneath the x-axis, but we go up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is the highest one on our chart. -3, 9, -2, 1, 2, 3, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Those are the table of values all plotted out, and you know that a quadratic is a parabola shaped like a U. and that's the parent function. So we'll put arrows on the end because we'll go on forever. The next parent function is the square root function, number 5. That's f of x is equal to the square root of x. Well, the domain of this, you know, you can't put negative numbers in that radicand. You know x has got to be greater than or equal to 0. So what we're going to do is we're going to set up a special table of values. We can't go negative on our x's. And what I'm going to do is I'm not going to go from 0 to 4. I'm not going to take every integer. I'm just going to take the perfect squares. 0 squared, 1 squared, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Because if we take the square root of 0, we're going to get 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. So then I don't have to worry about any radicals in my y table. I can just plot those out pretty easily. So our square root function, oh, and where's my ruler here? The square root function has a definite start. It does not go on and on forever to the left or down. Here is our point 0, 0, and we're going out to 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So those are the x values. And then our y values are 1, 2, 3, and 4. So 0, 0 is our first point, 1, 1 is our second point, 4, 2 is our third point, 9, 3 is our next point, and 16, 4 is our next point. Whoops. And if you remember the shape of an absolute or a square root function, it kind of gradually grows in this direction. This is an increasing, it's always an increasing function, but it has a definite starting point. Do not put an arrow on that end of a square root function. The next one is the cubic function, the last one that we'll do tonight, number 6, cubic, and that's f of x is equal to x cubed. Domain is all real numbers. But we're not going to start with -3 because once you start cubing 3, you're going to get 27, and that's usually too much for a graph. So we'll just start with -2, -1, 0, 1, and 2. We'll just use these five x values, and then we have to cube them. -2 cubed is -8. -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So we have five values that we're going to graph here. So let's take a look at what this looks like. Not too many x values. -2 to +2, and then our y values go down to -8. 1, 2, 3, 4, 5, 6, 7, 8. And then up 1, 2, 3, 4, 5, 6, 7, 8. -2, -8 is our first point. -1, -1 is our next point. 0, 0, 1, 1, and 2, 8. And this cubic curve is kind of an S-shaped curve, like this. Whoops, I should have gone through the origin better than I did. Put arrows on both ends because it goes up and down forever. Domain and range are both all real numbers. So what you're going to have to know is the shapes and the XY table of values. No basic shapes. So if you were to take a look at a graph like that, you'd know it's a cubic. If you were looking at a graph like that, you'd know it's a square root function. So basic shapes and the XY table of values that I just listed. And taking these table of values, that's when we can start doing our shifting and our reflecting. So we're going to start with shifting. So we're going to shift these graphs. First of all, we're going to do a horizontal shift. There's two types of shifts that we're going to talk about, horizontal and vertical. So let's start with horizontal. A horizontal shift is a shift to the left or right. And if you're moving something to the left or right, what you're doing is you're changing the x values. and we were keeping the y values the same. So if we want to shift something to the left or right, if you remember from Algebra 2 last year, I'm going to call this new function h of x, and h of x is actually f of x plus or minus c. C is a constant. C is how much we are shifting this function left or right. C is the amount of the shift. So if we want to shift something over 2, we're going to shift, let's say we want to shift to the left. Plus means left, minus means right. Just the opposite of what it seems. It seems like it would be plus usually means go to the right, but in this case, if you have x plus 2, you're going to be shifting it 2 to the left. If you have x minus 2, it means you're shifting 2 to the right. So we'll go through some examples of, a couple of examples of shifts horizontally. Okay, so let's say we want to shift a square root function to the left 3, and that'll be our example. Okay, so our h of x function is equal to the square root function, which is the square root of x. But if we want to shift it left, we're going to do a plus 3. And notice that plus 3 is underneath the square root function itself. It's not on the outside. If you put a plus 3 on the outside, it would mean you're going to shift it up. But this is a shift left 3. And if you're going to shift something left 3, what that means is subtract 3 from the x values. So left 3 means subtract 3 from all the x values on the table of the parent function. So we're going to start with a table of values of our square root function. So we're going to start out with f of x equals just the square root of x, just a parent function graph. And remember, the xy values are 0, 1, 4, 9, and 16. And the y values are 0, 1, 2, 3, and 4. And so when we're transforming these graphs, I'd like you to start with the parent function and then name what you're doing to the values here. What I'm going to do is I'm going to subtract 3 from all of the x's, and now I'm going to set up a new table of values. And this new table of values will have 3 subtracted from each one of these x's. So 0 minus 3 is negative 3, and you keep the y value the same. 1 minus 3 is negative 2. And you keep the y value the same. 4 minus 3 is positive 1, and keep the y value the same. 9 minus 3 is 6, and 16 minus 3 is 13. So here are our new xy values that we're going to be putting on a graph. So let's do that. So these x values go back to negative 1, 2, 3, and they go out to 13. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And negative 3, 0 is our starting point. Here's that first value. Negative 2, 1 is our second point. 1, 2 is our next point. 6, 3 is our next point. And 13, 4 is our last point. So then when we graph, or when we sketch this, it's got the same shape as the parent function, but everything's been shifted to the left 3 because you're starting back here at negative 3. So there's a left shift. Let's do a right shift of a quadratic. Here's our second example. Let's shift a quadratic right 3. So what would that function look like? Well, h of x is equal to, well, the quadratic function is x squared. So if you want to go right 3, it's going to be minus 3 and then square it. So notice that minus 3 is on the inside of the parentheses. If I wanted to shift something down, this minus 3 would have to go on the outside of the parentheses. But inside the parentheses, or inside the function itself, is the plus or minus. So that means right 3, Oh, that means you're going to add 3 to the x values, and that'll shift it over 3. So what we're going to start out with is the f of x is equal to x squared, the parent function table of values. So x and y, if you remember our xy table, you start with -3 and go up to +3 and square each one of those numbers. Okay, so there's our xy table for just plain old x squared. Whoops. And then we're going to make a new table of values by adding 3 to all the x's. So then we're going to shift that whole parabola, whoops, to the, I'm sorry, yeah, that will shift it to the right 3 if you add 3 to all the x values. It's the opposite of what is in this parentheses. So let's make our new xy table. So we're just adding 3 to all these numbers. -3 plus 3 is 0. -2 plus 3 is 1. -1 plus 3 is 2. And let's keep the y values the same. 9, 4, 1. 0 plus 3 is 3. Keep the y the same. 1 plus 3 is 4. Keep the y the same. 2 plus 3 is 5. Keep the y the same. And 3 plus 3 is 6. And keep the y the same. So there are new values that we're going to be plotting, 0, 9 up to 6, 9. So let's get our xy axes set up here. Now I don't have to graph anything below the x-axis on this, so I'm just going to make that y-axis underneath there pretty small. So I'm going to start with x equals 0, and we're going up to x equals 6. 1, 2, 3, 4, 5, 6. And then the y values go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0, 9 is our first point to plot. 1, 4 is our second one. 2, 1 is our next. And 3, 0 is our next one. 4, 1, 5, 4, and 6, 9 is our last one. So now we're just going to connect these in a nice parabola. And now you've seen this parent function being shifted over to the right by 3. The next type of shifts I want to talk about are going to be the vertical shifts. And that means up or down. And when you are shifting something up or down, you are changing the y values. So if you want to shift a function, let's say h of x is our shifted function, you're going to take that parent function, f of x, and notice it's not inside the parentheses this time, it's outside the parentheses, it's plus or minus c. So notice this is outside the function. This c value is outside the function. So plus c means up, c units. And minus c means down, c units. So let's get a couple of examples. Let's take an absolute value function and let's shift it down 4. So here's our example. Ex, for example. Let's shift an absolute value down. Let's go down 4 this time. And if we're going down 4, that means we're going to take all those y values and subtract 4 from them. So that's our little note. Subtract 4 from the y values. And that'll move the whole thing down. So let's start with f of x is equal to just our parent function, absolute value of x. Get our xy table set up here, and if you remember the xy table, we start with -3, -2, -1, 0, 1, 2, and 3, and the absolute value of all these numbers. So there's the parent function. And what are we going to do? We're going to take 4 from those y values, so we're going to say y minus 4 and set up our new table of values, and these are the points that we're going to plot. So keeping the x's the same, 3 minus 4 is -1. 2 minus 4 is -2. 1 minus 4 is negative 3. 0 minus 4 is negative 4. 1 minus 4 is negative 3. 2 minus 4 is negative 2. And 3 minus 4 is negative 1. So now let's set up our xy axis so we can graph this absolute value function. See, our x's go back to negative 3 and go out to positive 3. Now it looks like our y values go down to negative 4. So negative 3, negative 1 is our first, whoops, it's kind of in the way of my point here. I'll put that negative 3 right there, and that'll be in the way also. So I'll put those scales up here. So negative 3, negative 1 is the first point. Negative 2 is our second point. Negative 1, negative 3 is our third point. And 0, negative 4 is y-intercept. And then we're just going to climb right back up the other side. And then we're going to connect these, and you can just keep on going. So this is our absolute value v that's been shifted down 4 units. Now let's, for completeness, let's shift something up. Let's shift a quadratic up. Let's go up 2. So f of x, no, h of x is what we call our shifted function. So we're going to say h of x is equal to x squared plus 2. Notice the plus 2 is not inside parentheses like it was before. So if it's up 2, we're going to be adding 2 to the y values. That moves that whole parabola up 2. So we're going to start with f of x is equal to x squared. That's our parent function table of values, negative 3, negative 2, negative 1, 0, 1, 2, and 3. And then we're going to square all these numbers, 9, 4, 1, 0, 1, 4, 9. And now if we want to add 2 to the y values, we'll indicate y plus 2, set up our new xy table, and the x's stay the same. And now we're going to add 2 to all these. So 9 and 2 is 11, 4 and 2 is 6, 1 and 2 is 3, 0 and 2 is 2, 1 and 2 is 3, 4 and 2 is 6, and 9 and 2 is 11. So here are our new xy values that we're going to be plotting. So it looks like it's going to go up to 11. So we've got to do a pretty tall y-axis here. We don't need to go underneath the x-axis at all. So we have x's going back to negative 3 and out to 3. And y's are going up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So negative 3, 11 is our start. Negative 2, 6. Negative 1, 3. 0, 2 is our y-intercept. 1, 3. 2, 6. And 3, 11. So here's our parabola. Nice U-shaped graph with arrows on the end. So there you go. And that's a complete list of shifting examples. The next thing we're going to do, and the last thing we're going to do, is reflecting. Okay, let's say we're going to reflect in the x-axis. We're either going to reflect in the x or y-axis. So let's start out with the x-axis. If you reflect something through the x-axis, what you're going to do is negate the y values, if you remember from geometry. Okay, so let's see what this looks like as far as h of x goes. If you are negating the y values, then that negative has to go outside of the y. And remember, y is the same thing as f of x. So that's what a reflection looks in the x-axis looks like. The negative goes here. If you're reflecting in the y-axis, though, when you reflect in the y-axis, what you do is you negate the x values. So the reflection, this reflected graph, is equal to f of negative x. Notice the negative goes inside parentheses because you're negating the x values, not the y values. So let's do a couple of examples, and then we'll be all done for today. Let's reflect a parabola in the x-axis. Let's reflect a quadratic in the x-axis. We wouldn't reflect a quadratic in the y-axis because it actually turns out to be the exact same graph, if you can think about it. So this h of x is equal to the negative x squared, not negative x in parentheses, but negative x squared. So we're going to negate all the y values from the parent function. So we're going to start with our parent function table of values, -3, -2, -1, 0, 1, 2, 3. You'll get real good at this after a while. 9, 4, 1, 0, 1, 4, 9. So there's our parent function. This is f of x equals x squared. And now if I want to negate all those y values, I'm not going to write a whole new table out because that would kind of be a waste of time. If I want to negate the y values, let's just put negatives in front of all those y values. So that is our finished table. And now if we wanted to graph this thing, we're going to go out to -3 and then down to -9. Oops, -9. -1, 2, 3, 4, 5, 6, 7, 8, 9. So here we go. -3, -9 is our first point. -2, -4 is our second point. -1, -1, 0, 0, 1, -1, 2, -4, and 3, -9 is our last point. And now this is a quadratic, so we're going to draw a nice little parabola if we can be a little more artistic than I am. Sorry about that. And there we go. There's a reflected. The parabola has been reflected in the x-axis because we just negate the y value. So this is what that function looks like. And the last one, let's take a square root function and reflect it in the y-axis. So our last example of the night, reflect square root in the y-axis. And if you reflect in the y-axis, that means you're negating the x values. So what does that look like as far as our h of x function? Well, if you remember, if you're negating the x values, the negative has to go in front of the x. It can't go on the outside of the whole function. It goes next to that little x. So when you do the square root, it has to be a negative x on the inside of parentheses, not on the outside. If you had the negative out here, you'd be reflecting it in the x-axis. This is a reflection in the y-axis. And if you want to prove this to yourself, you can always pull your graphing calculator out and take a look at that. So what we're going to do is we're going to set up the x, y values for our f of x equals the square root of x. So 0, 1, 4, 9, and 16. 0, 1, 2, 3, and 4. There's our parent function. And now if we're going to negate all those x values, just throw a negative in front of all those x values. And if you want to put in this, if you want to prove it to yourself, if you plug in a -1, a -1 is a +1. So you can take the square root of that. -4, -9, these will make all of those turn positive. So these x values go out to -16. So I'm going to put my y-axis way over to the right to give myself some room. And this goes back to -16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the y values go 1, 2, 3, and 4. So 0, 0 is the starting point. -1, 1 is next. -4, 2 is next. -9, 3 is next, and -16, 4 is the last one. So you can see the square root function has been reflected. Normally it goes this way, but it's been reflected in the y-axis. And that's it for today. We will be practicing this in class. Good night.